This experiment is all about writing an assembly language program to add two 16-bit numbers, and we have to consider the carry also. Okay, let's try to build up the basics by taking some example. Okay, let's take two random 16-bit numbers. Let's say the first number is 6, 7, 8, 9. Right? This is an hexadecimal. And the second number is, let's say, 1, 2, 9, 3. Right. So, these two numbers are of 16 bits, and we have to add these two numbers. Okay, and if we remember the architecture, all these registers where our data is supposed to be stored, it's all 8-bit. So it's impossible to store the 16-bit number in a register. So we have to take two registers, two memory locations or two registers to store the 16-bit numbers. Okay, so what we have to do is we have to divide these 16-bit numbers into bytes as lower byte and upper byte. Okay, and for the second number also we can divide the 16-bit number into lower byte and the upper byte. Okay, and this bytes has to be stored at different registers. Okay, so let's we can store these numbers or these bytes anywhere in this internal RAM, or we can use external RAM also. For simplicity, let's say we're taking this register bank 0, and we're going to store these bytes into these register banks. We can store anywhere, but for simplicity, we can store in this register bank. Okay, let me draw this. Okay, let me draw this register bank 0. Okay, this is register bank 0. This is register 0, register 1, 2, 3, 4, 5, 6, 7. Okay, this is name of the address, name of the register, and the address is 00, 01, 02, 03, 04, 05, 06, 07. Let's say we store this 89, which is the lower byte of the first number, into this 00 or R0 register, and this 67 to the R1 register, and 93 to 02 and 12 to 03. Okay, okay, it has 89, 67, 93 and 12. So the process is like Since we cannot directly add these 16-bit numbers, we have to add this lower byte separately and this upper byte separately. First, we have to add this two lower bytes, this 89 and this 93, or we can say the content of R0 with R2, with the content of R2. Okay, this is lower bytes, this is upper bytes. Okay, if we add this two lower bytes, we get C 9. If we add 3 to 9, A V C, and 9. If we add 9 to 8, 9, say A V C D E F 0 1. So this is 1, and there's a carry generated from this to this. Okay, and this is the result. The lower byte of the result can be stored somewhere like this R6. Okay, what about this upper byte? 7, 9 with a carry. This is A 7. So this is the upper byte of the result, and we can store this result at some registers like 07. So this R6 will contain 1C and 7A. Okay. Okay, this is the result. Okay, since the result is of 16-bit, it has to be stored in two registers, and we are putting here in this R7 and R6 registers. To perform this kind of operations, we can approach this kind of experiment in two ways. The first way is we can define the two numbers which we are going to add at the program itself. Okay, like this. Okay, in this example, we predefine the number which is going to be added. This is one way, and another way is we can define the placeholder, or we can say the variable. Okay, the placeholder will be like the name of the register. Okay, and we can put the content of the register afterwards at the time of debugging. Okay, and in that way, since we can put the numbers which are going to be added like afterwards, this is more flexible, since we don't have to predefine the numbers. Okay, we can see these two ways by taking an example, and we can see better in that way. Okay, let's take some example program. Okay, let's start writing program by mentioning the starting address of the memory location. And in this program, we're going to use the carry flag, so it's better to clear this flag. Okay. Okay. In the examples that we have taken, we took 6789 and 1293 as the two 16-bit numbers. So this 89 and 93 has to be added first. Okay. And for the arithmetic operations, these numbers has to be put in the register A first. So let's copy this 89 to the A first, and we can add the content of A with this immediate number 93. Okay, let's do it like that. So in the next instruction, you can say move A, comma, 89 H. Okay, we have, okay, since we are using the immediate number, we have to put hash before the number. If you don't put, this 89 will be treated as the address, of the register, and the content of that register uh, is going to be copied to the accumulator. Okay. So in the third instruction, we have copied, or we have load this 89 to A, and then we can uh, add A with 93, right? Okay. So in the fourth instruction, we are going to add this 93 with the content of the accumulator, which is 89. Okay. And uh, sum of these two numbers will be stored in the accumulator, which is the lower byte of the result. And we can store the lower byte of the result in some registers, like let's say R0. So what we can do is move R0 A. So in the fifth instruction, we are moving, or we are storing the lower byte of the result to the register R0. Okay, and for the upper byte also we can do the same thing. Okay, we can do the same process, copy, and we can bash. This number is 67 7, and the upper byte of the second number is 12. So in the sixth instruction, in the sixth line of instruction, we are copying, or we are loading A with 67. Okay, and in the seventh line of instruction, we are adding 1 2 with the content of A, which is 67, and the result. Okay, and result means the upper byte of the result is stored in the accumulator A, and this accumulator A and this the content of accumulator A can be stored to some registers like R1. Okay. So this R0 and R1, R0 contains the lower byte, and R1 contains upper byte of the result. So in this case, in the second addition, we have to take care of the carry also. So we will use this instruction ADDC, since there's possibility that the carry is generated from the lower byte. So we have to use this instruction ADDC. And we can end our program here. Okay, that's it. And the sum is 7A1C. So 7A is the upper byte of the result, and it is supposed to be stored in the R1 register, and 1C, which is the lower byte of the result, is supposed to be stored in the R0 register. So let's see. Okay, let's save this. .asm. Okay, we're storing this text file as ASM file, and after that this 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 is highlighted. Okay. Okay. The next step is go to target. Okay. And source group. Okay. And we can add existing file 16 edition. We can add the already we can add the ASM file which we created. Add and close. And if we expand this source group, we can see this ASM file. Okay. And the next step is go to the project and options for group source, and then click OK and go to the project again, option for target, and just uncheck this, run to man, and click OK. And we can translate the our program and will, and that's all. And the next step is we can debug. And we can debug step by step. Okay. And debug step by step. As we can see, this this R0, which our lower byte of the result is supposed to be stored. It contains this 1C, and then this R1 contains 7A, and this is what we are expecting. So let's stop the debugging, and let's rewrite the program. Let's rewrite the program in such a way that instead of redefining the operands, we can take the placeholder, we can take resistors as the placeholder, and we can do additions like in general way. Okay. Instead of taking this 8, 9, we can take a resistor like R0, and then in this case, in this situation, we can use two resistors like A and B. So the lower byte, okay, the lower byte of the first number is supposed to be stored in R0, and it is that lower byte of the first number is loaded to the accumulator. And in the same way, we can load V with, say, for example, R2, which has the lower byte of the second number. And then we can add A and B. Okay. And then we can add A and B. The result is, suppose the result means the sum of the two low bytes, okay, and the sum is supposed to be stored in the accumulator, and that sum or the lower byte of the result can be stored in some locations like R5, and we can do we can write the program in the same way for the upper byte also. Copy, and we can paste. Okay, in this situation, for the upper byte, we stored in R1 and the R3. R3. And then in the next instruction, we are adding the content of A and B. Okay, and the sum is stored again in the accumulator, and that sum it can be stored in some memory locations like we've used R5, so we can use R6. Okay. In the addition of upper bytes, we have to the carry generated from the low. We have to use ADD C instead of just ADD. So this is the program. We can save, translate, fill. Yeah, that's it. We can debug right now. Let's debug. So we have to manipulate the content of res. We have to manipulate the content of res. Open the memory windows. This is the okay. In the memory windows you have to if this screen is not popping up on your, so you have to write the loan and the address which you are in my case the start is 00, so I have to write the colon 00. Okay. This is for the RAM. If you want to see the content of your ROM or you can type C colon and the starting address and then enter and it's popping off. Okay, this first 00 is the content of R0 register, R1, R2, R3 and so on. So in my case this R0 contains the low byte, the first number which is 89, which is 89. Second number, this second register R1 it's the upper byte of the first number, which is 67. This third register, which is R2, is supposed to contain the byte of the second number, which is 93. The register R3 it contains 12, and from the program this R5 is supposed, R5 means okay, this is 3, 4, 5. This R5, this register is supposed to contain the load of the result, which is 1C, and next register R6 is supposed to contain byte of the result, which is 7A in my case. So let's see. Okay, we can step by step. As you can see, this R5 1C right now, as we go, R6 contains 7A. In this way, you can do addition without predefining the numbers, and this is generalized way of doing addition. And you can put any numbers in this register. You can check yourself.